Hi everyone, my name is Grant and I'm here to show you my musical AI journey at DSR. I'm a software engineer by trade, but I also make electronic music under the name 16 Faces, and I run a small label with a good friend of mine in Australia. I also run some community events where we help producers to understand their music and get their productions a bit further forward. One thing that's always come up in these community discussions is beginners learning to turn loops into tracks and understanding their arrangement and trying to get a song out of their ideas that they've got. At the moment, the current tooling on the market is quite generic. Some of it takes away the musical agency by doing all the work for you. And if you're looking for professionals to help, they can be very expensive or hard to access. I did a bit of data digging on this problem, and across kind of 5 big surveys that I found, writer's block came up as a very big top 3 problem that all producers face. You can see some quotes here from a study or a small survey I did with some producer friends of mine. I tried to incorporate some of these ideas into my app. The biggest takeaway I got from my research was that actionable feedback is kind of the key to a successful AI project. There we go. I presented my solution, AI Music Mentor, the Techno Edition, getting practical AI advice in the tone and style of Berlin producer 16 Faces. First, let's dig into a few musical concepts, because I'm not exactly sure how many of you here have played around with Ableton or Logic or anything like that. I wanted the focus of my project to be on getting stuck on arrangements and how to get past that. Techno is a music that's basically built a lot around rhythm and energy, and so I honed in on these as the main core musical components. Harmony and melody obviously are part of it too, but they're far more complex, and for the time frame, I felt like this was enough to describe what makes a techno track. We can think about our music in terms of sections. You might have an intro to a track, an A medium groove section, a B, a kind of big hook section with this loads of energy, or a breakdown where the drums disappear and maybe you have like a more emotional release moment. We can also describe our music in waveform, as I'm sure many of you have seen things like this before. This is essentially just looking at the intensity of frequencies over time. Okay, so I'm a producer. I've got all these loops, but I have no idea how to order them. I've been making musical ideas, but I'm really not sure which is the main hook. And I've been working on this track for weeks and weeks, and I'm stuck. I've lost context. I've heard it so many times that I don't know if it's good anymore. If only somebody could help me. Okay, good thing we have AI Music Mentor to help. I was using it the other day and it gave me some advice to look at adding some percussion to my track to increase the intensity and give it a bit more dynamic. Let's have a look at what that might look like. I have a track here that I've been making. I'll try and do this from this awkward angle. We can have a quick listen. So you can hear it's quite groovy and deep, but the drums are not really that intense. So I've gone ahead and added some extra bits for us to have a listen to what it could sound like if we added some extra layers. Okay, cool. I think you get the idea. Our track is sounding a little bit better. Writer's block has struck though, and I don't know what to do with my track. So I'm going to switch over and we're going to have a look at what our Music Mentor can do for us. I've taken the liberty of exporting it earlier. This is the track. We can basically input a track here as our input track, as well as a reference track down the bottom, a professionally finished one. I picked one from my friend Pino because he's always got really good arrangements. And I add a little prompt here. You can see that I've added extend my arrangement and polish the sound as our kind of main goals for our advice. Cool. This is going to be cooking for a while because it's... So you're probably wondering, how does it all work? Be prepared. This is about to get a little bit technical. This is our system. Any questions? I'm just kidding. I mean, obviously this looks quite complex and it's a bit overwhelming. I'm going to try and break it down for you a little bit. There's two main components to it. We have an arrangement classifier. We take our music and basically extract meaningful features from it to give it to our neural network. This neural network then predicts our arrangement in these like A, B, C type style moments. And then from that, we're able to predict or at least give some ideas of how we can improve it and then also visualize it for our producer to see. The second part is a RAG pipeline. The RAG pipeline basically is a retrieval mechanism. So we look for songs in our database. Those songs are associated with professional producer feedback that might be relevant. And then we extract those and filter them and send them to our main output. The feature extraction was done by Librosa. I don't need to dwell too much on this. Essentially, we take musical ideas and they're put into metrics so that our system understands them. And we get a 19-dimensional vector to kind of explain that to the system. Next, we look at the CRNN. So this is our neural network. It's a hybrid architecture, a convolutional recurrent neural network, which is a bit of a mouthful. Basically, I found an architecture like this online that someone else had already made, and they had trained it on chorus detection. You can see at the top, this is what the output looked like before I started fine-tuning it. Essentially, it's finding areas in the song that it thinks are a chorus, and it's not doing a great job, but it is finding something. I fine-tuned it and looked for a more complex arrangement pattern. So basically O, A, B, and C. And as you can see here, it kind of gives you a better understanding of what's going on. So what is a CRNN? This is a hybrid architecture that uses convolutional layers. They essentially look at like 5-second chunks of audio to sort of understand musically what's going on with them. These are then passed on to recurrent layers that are LSTMs, and these look at the sequential nature of a song. So you have your 5-second chunk, and you want to understand how does it fit into the overarching picture of what is musical. This was then passed on to our classification head. The classification head is the part that I fine-tuned. It's a new part that I added. Essentially, the frozen bits, the convolutional layers, and the LSTM, they hold information from the previous training, and then we bake in some new understanding into the final head, and then we're able to predict O, A, B, and C sections for every 5-second chunk of music. The training data I used, I had to label manually myself. So I used 30 songs that had these 4 different classes in them. I then also augmented this data. So for every track, I time stretched them to make them shorter or longer to kind of give the impression of more data. And we were able to get to a similar per class data point to the original training. You can see from the metrics up here that I tried a 3 and a 4 class output to see what would be different. On paper, the 3 class is actually better, but in practice, the 4 class one was more practical when I tried to use it for the actual application. So that's basically what I decided to stay with. Our RAG system, which is retrieval augmented generation, I think Acel already dived into what this is. The difference with my system is you're basically comparing audio embeddings rather than text embeddings. So essentially, we upload a song, we look at songs in the database to see which ones are similar to that. Those songs in the database are then attached to text from our producer. We retrieve a bunch of them. We then also filter those. So we have a small LLM, which is looking at our user prompt and then also at the feedback and saying, is this relevant? Is it actually about extending an arrangement, for example? And then we throw away what we don't want and we just take the top 2. These are then passed on to our main prompt and to a bigger LLM for our main output. You can see some of the technology I used here for the RAG that way. I use cosine similarity search for our embedding search and 2 different LLMs, Llama 3.2 for the filtering, and Qwen 3, which has a thinking component for the larger output, which was a bit more complex, and PG Vector, which is a Postgres vector database. So prompting was the next step in our pipeline. This was definitely my least favorite. I would equate it to herding cats. It's very much an art and not a science. If you're interested to know what went into the prompt, there was a lot of stuff, but our predicted arrangement, the global features, a comparison between the input and output track, the feedback that we've retrieved, and a few other bits and pieces, also using a graph of thought approach for understanding. So you can see here that our text output has a few different aspects to it. We have a musical arrangement understanding that's predicted using these letters. It tells us kind of what's going on with our track at the current state. It also gives us two key suggestions of things that we could consider to change in our track that we can implement ourselves afterwards to see, basically to get out of writer's block. And finally, it ends with some supportive notes to kind of encourage us to get going, because I mean, that's what I would do if I was trying to help someone as a human. So that's in there too. We also get this lovely visualization. So this is what's coming out of our CRNN and the visualizer service. You can see the track at the top here was the one that we were working on earlier. The red section is a high energy section. This is where we laid in extra drums. So you can sort of see that the network is looking at it and seeing there's more activity there, and that could be our main hook. You also see the reference track below it, and this is a nice comparison to see how is my arrangement stacking up to a professional track so I can make better decisions. So hopefully that shows you that we've got some useful ideas that we can work with and then a nice visualization so we can better understand what our track is doing. In terms of evaluating it, as some of you probably know, LLMs can be really quite difficult to deal with. Text is inherently subjective. I created a little survey that I did every time I was improving the system, and you can kind of see from the diagram above, over time it's improved. I mean, I updated more feedback data, I changed the prompt several times and changed different sizes of LLMs to see which could handle what, and we got some definite improvement, although it's definitely not perfect either. Also, just to avoid the fact that I'm obviously going to think my system is awesome, I sent it off to some friends. I gave them a blind test. So essentially they got a ChatGPT output and then an AI Music Mentor output for the same songs. And then they did a blind test and equated them on the same survey that I was using earlier. You can see that we're doing pretty well. It didn't do amazingly, but this is like a pretty complicated project and I didn't have the time to refine every aspect of it. But yeah, I think it did a pretty good job. So the main challenges were, I guess, the time and the fact that there were so many moving pieces. I use global embeddings for a lot of the music stuff, and so you kind of get this averaging out. Like it's hard to describe a song from the average of its rhythm, for example, or the average of its energy, for example. The prompt engineering and trying to get my own personal style of like text and speaking into the output too was a little bit challenging. If I had a little bit more time, I would add loads more data. I would probably add some more sophisticated classification as well. And I would consider chunking the audio in the database. So we could have A sections and B sections separately and then actually compare them against each other in a more meaningful way. A friend of mine who did the survey left me with this nugget of wisdom. So if anyone knows anyone important at SoundCloud, let me know. Yeah, I mean, thank you so much for your attention. Thank you to Christoph for the mentoring and to all of DSR. Dennis Dang was the young gentleman that let me use his CRNN. And to my friends, Joe, Pino, Dirk, Michael, and Adrian for their trust.